This piece is called Drapery for a Seated Figure, and it's by Leonardo da Vinci around 1478. There are some really obvious design elements here being used. The first one that caught my eye was control points. Looks kind of like this. Then the question for me becomes, what does that point mean mathematically, and what is its relationship to the whole? So that's what I'm going to try to look for. But before we start, it's worth mentioning, where do we get this idea for control points, or most of our ideas in classical design? And that's from nature. I mean, that's essentially what a tree is, a giant control point going into the ground. But plants are doing that at every level, even on the small scale, in grass, in say our backyard or the field near our house. And they're even competing for dominance in those directions amongst themselves. They just tend to be not as rigid and defined as our clumsy mechanical systems that we've created based on them. They're a lot smarter than that. They're going to do whatever it takes to survive, and most of the time that's a little too complex for us to wrap our heads around. But that's basically the foundation of everything classical design, and you can find that 3000, 5000 BCE if you're looking. Okay, first thing I'm going to do is take measurements, because it's probably a combination of overlapping rectangles or two side by side that are longer and thinner, or verticals, and I need to see if those measurements are any ratios of compound structures I already know. And nothing comes to mind, so my first try here is going to be just with squares, and we're going to see how they interact inside this really short rectangle. And here's the first clue. I think I found something. This looks like the division in the squares is creating that vertical that control point is derived from. And that should have led me right down the obvious path of root 4s, or overlapping root 4s, because the square root of 4 is 2, that's 2 squares side by side. And it would have made sense, but I did fumble around with 1.5s on top of each other, then whirling squares on top of each other and side by side. Or it wasn't working exactly, and I thought about it for a while, and I went right back to the root 4, and it made perfect sense. Well, all you have to do is stack them side by side vertically, and one of the initial divisions created by the reciprocal is actually a perfect overlap. Then it's just a matter of adjusting the control points a little bit so that they hit those grid lines, and boom, there it is.